Okay, you can see I'm here in my classroom, and really none of you are here. So I'm guessing it's because it was 4:30 today. I turned my little video off, and I'm going to talk our way through an introduction to integers. So you'll all be watching this on YouTube tonight. I've got no one online, so I'm going to go through it relatively quickly. And at places I'm going to ask you to stop and think about what you're doing, and then I'm going to ask you to restart. I'm also hoping that all of you at this point have got and are using the notes, the Cornell notes sheets that I sent you called Math Toolbox. So I'm just going to go offline for a second, and I'm going to find my copy of Cornell notes, and then I'm going to share it with you. Oh, and here's Jasmine. Hi, Jasmine. You're the only one here so far. So I was just saying that I was going to share a page with you guys that shows the Cornell notes. Now, I have to remember how to do that because it's been a while since I've used any of the other things, but I think I'll bring up a blank page. There we go. And then I'm going to go offline for a second, and I'm just going to get a copy of the Cornell notes and paste it here so that you remember what we're talking about. And then you're going to be able to use it. So there it is under downloads. Hopefully this works. Okay, I'm back. Okay, it didn't work. So, well, I was going to try and do that, but I can't. Okay, so we're just going to move on. By the end of the unit that we're doing this time, and I'm hoping to be done by spring break, you will be able to represent addition and subtraction of integers using concrete materials, drawings, and number lines. So I'm going to show you how to do one of those today. We're going to use some of those concrete materials at next class. We're going to do a little quiz at the beginning to know how much you already know about integers. So we know that you're going to have to be able to record addition or subtraction of integers symbolically. That means just using a regular addition and subtraction statement, and solve problems. So those are the things that we're working on today. So first of all, what we're looking at is a chart that I took off of the weathernetwork.com this morning. And this chart shows the temperatures from Thursday of last week, Thursday, actually it's from today, no, tomorrow. Today's Thursday, today's Wednesday. So starting tomorrow, this is what our temperatures are going to be like for the next couple of weeks. And you can see actually that it's going to get colder. And right now it's quite warm. So I'm just wondering if you can think for a second, what do you see as the highest temperature on this chart? What is the highest temperature on this chart? And Jasmine or Lexi, if you know that one, you can just tell me, and I will point to it. So the highest temperature anywhere on this section of the chart. Jasmine, no, she's got her hand up. Oh, maybe I don't have enough stuff out. And are you okay to type, Jasmine? You guys have got, should have just about everything. So 12. So she says that the highest is 12. And in fact, if we look here, it's 12 degrees Celsius. And that's going to be Saturday and Sunday, not this weekend, but the next weekend. Now that could change, of course. What is the lowest temperature on this chart? What is the lowest temperature on this chart? So we're going to take a look through all the low temperatures. It's going to be on this bottom line. The top one is the highest for the day, and the bottom line is the lowest for the day. So the lowest temperature on the chart, Lexi says, is -2, and she's absolutely right. It's right here. Now what we want to know is what is the difference between the warmest and the coldest temperature. So we have 12 degrees Celsius. Here comes some fancy writing again. I'm going to see if I can find my mouse and where my atrocious desk. And I can't. All right, so 12 degrees Celsius was our highest temperature. What is the difference between, Jasmine's got it, 14. And the difference is that we start at 12, and we reduce our temperature. It gets colder and colder and colder, and it gets all the way down to 0. So there we've taken 12 away. 12 minus 12 is 0. So now we have to go down to -2, even below 0 in temperature. And to get to -2, we have to go down 2 more. So what we've done is we've moved from 12 to -2, and that is -14 degrees. So it got 14 degrees colder over that time. And that's what we're going to talk today about, the difference in temperatures. So what are integers? And this is the part that would go in your Cornell notes. So you might want to pause right now and take a few notes. Integers, they're all positive and negative numbers. So all of the positive and negative numbers are integers. So what do we mean when we say negative numbers, and where do we use them? Well, we just saw one example right there. We saw a negative number is used when the temperature drops below 0. Is there any other way that we use negative numbers? So I don't know if Jasmine and Lexi will know this, but I'll give them a second to think about it. And I'm not seeing a whole lot of typing going on. Oh, no, Jasmine's doing some typing. She's going to tell me some stuff. So one of the things that we know is that negative numbers can be used in what they call a plus minus. And a plus minus is a hockey score. So if your team scores and you're on the ice, and then you get a plus. So that might be +1 or +2, but you get a plus. Then, if you are on the ice and the other team scores, you get a minus. You get a minus every time that happens when you're on the ice. Even if you're on the defense when the other team's on a power play, it still doesn't matter. So, sometimes you might have a plus minus that's negative. What does that mean? It means that you're on the ice more when the other team scores than when your team scores. And you better have a good explanation for that for your coach. The other time that we might use this, and happens quite a bit, is the distance below sea level. So we know that if we are diving, if we are scuba divers, then when we go down in the water, we'll measure our distance down from sea level. So we might be -30 or -40 feet. And it also is the way that we measure distance from sea level on land. So there are places on the earth where the earth is actually below sea level, and then we say that their elevation is a minus elevation. So those are all areas where we use negative numbers, and we'll experience a few more in the next couple of weeks. Now, what do we mean when we say a number is positive? We mean that number is above 0. Usually, when we see a negative number, there is a little minus sign in front of it. So I'm going to write out a negative number here. It might be -10. Now that might be your plus-minus score, in which case you're a lousy hockey player. Or it might be how cold it is outside, -10 degrees Celsius. Or Fahrenheit, depending on where you are in the world, because I use both those systems. Either way, that's cold. All right? So, when we say a number is positive, we mean it's a number, like the number 1 or the number 2,000. The thing that we don't always do is put a positive sign in front of it. But for the sake of the next couple of weeks, just so that we remind ourselves whether a number is positive or negative, you'll often see this. A little plus sign in front of the number. That means it's positive. So that is the notation for positive and negative. And if you're making Cornell notes, this would be a good time for you to stop and write what are integers, and then say they're all the positive and negative numbers. We know that we put a minus in front of a negative number and a plus in front of a positive number. I'm going to keep going, so if you've paused, you'll just hear my wonderful voice when you start up again. So, we use negative numbers for statistics, temperature, elevations below sea level. There are lots of things that we use them. So what does it mean? What does below 0 mean on a thermometer? What does below 0 mean on a thermometer? So I'm waiting for Jasmine and Lexi because they're actually online. Jasmine says it means it's cold, and she's right. It does mean it's cold. So a couple of nights ago, it got below 0 on the thermometer, and that meant that a bunch of us in the morning had to scrape our cars before we came in the morning, or I actually had to wear a big tooth when I was riding my bike. So below 0 on a thermometer means that it is really cold. Now, what does it mean to become more negative? What does it mean to become more negative? Anybody got a thought on that one? Jasmine might have. I see your little number lighten up. To be more negative in a thermometer situation means that it's actually getting colder. So if we add negative, we will add a negative number, we will get more negative. It's an increase in negativity. And I'll give you a great example of this in the next class. All right? So it's more negative. Now, what if it warms up? So maybe we start the morning at -10. We start the morning at -10. And then by the end of the day, it is -2. How did we get there? Well, what we did was we subtracted negatives. So often, in order to stop us from being confused about where the negatives and positives are, the numbers and all of this stuff, is they will actually put brackets around numbers. And you'll see this a lot better done in the textbook, I can tell you that much. All right? So that's what it means to become less negative and more negative. So, do you know what the zero principle is? This has to do with comparing integers, and this is a big thing that we're going to learn today, and we're going to practice in class maybe next time with some manipulatives. So, the zero principle means that if you have a positive and you have a negative, in the case of the picture below, the negative is yellow. If you have one positive and one negative, what do they end up being? What do they end up being? Anybody have any idea? They end up being 0. So, say we have -1 and we have +1. We put them together and we get 0. So that is called the zero principle. And what that means is every time you have a plus and a minus together, you have 0. So this is one way that we can figure out how to add. So below shows the number line, the number picture, sorry, for -4 plus +5. Okay. What is the answer? Anybody want to take a guess here? Jasmine says 1, and she's right, because we've got 1 0 pair here, 1 0 pair there, 1 0 pair there, 1 0 pair there. That took care of all of our negatives. We got nothing negative left. All we've got is +1. So that is exactly what I want you to learn in the next couple of days. And the answer is Mrs. Fair doesn't have her pen yet. Oh, because it's on yellow. The pen likes to be yellow. The answer is +1. So that was easy. So I want you to remember we actually use red and blue an awful lot when we're doing math, just because our integer discs that we use are red and blue. So you might want to do that. All right. So let's model some questions with integer discs. We have -9 plus +6. And if you've got paper, you can start doing this now. And we have -7 plus +7 plus -3. So I'm going to try and I'm going to get my circle. I'm going to make it. I'm going to try and change the color to red. All right. I'm going to see if it shows up here. So I'm going to use red as my, so there's 1, 2, 3, 4, 5, 6. Okay, and again, pretty? Not so much. And then I'm going to change my color to yellow, because that's the other side of the disk. And I'm going to draw myself 9 negatives. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I look at my pictures and I take out the 0 pairs, what have I got left? What have I got left? +3. That's right. And just for the sake of this argument, let's make sure that we put that positive sign in front. I know we know what it means, and we're going to put that positive sign in front. So we have +3. So if you can't figure that out, we're going to do one more just to show you. And these are using 0 pairs. So red is positive and yellow is negative. So I'm going to clear the page. Okay, and I'm going to go back and I'm going to get my yellow. I'm going to start with my yellow because it's easier. I've got 3 negatives. And I've got 7, or sorry, how many positives do I have? 7 positives. Here we go. 1, 2, 3, 4, 5, 6, 7. All right. So -3 and +7. All right. So take a look here. We've got 0 pairs, and we have 3 of them. So here's one. I'm going to get my. Here's 1 0 pair. Here's another 0 pair. Right here, and another 0 pair. So there's 4 red left, and what do the red represent? Positive or negative? Just waiting for an answer. They represent positive. That's right, Jasmine. That's right too, Lexi. So if they represent positive, what is the answer to positive 7 plus negative 3? Positive 4. Absolutely, ladies. That's excellent. So now we're getting how to model these with integer discs. We write down, we have to use 2 colors. I'm not going to be picky on your homework what colors you use, but I do want you to use 2 colors for these, or use pen and pencil if you don't have colors at home. But what I want you to do is I want you to draw the next questions, and these are going to go on your Cornell notes on the back. I want you to draw negative 5 plus positive 9, negative 7 plus negative 3, negative 4 plus negative 5, and negative 8 plus positive 3. And I want you to remember these 2 things. First of all, red, if I've got a red circle, that is positive. Oh, it's not bringing up my pencil. No, it's just trying to make me write that too. Okay, red is positive, and yellow is negative. Now the next thing I want you to remember is that, when, like I did in my pictures, and I'm going to show you this in a second because I've got 1 minute left. That's negative. Okay, I'm just going to go back 1 page and I'm going to show you something, how I did that, and I don't know if you noticed this or not. All right, so I'm going to go back a page. When I was drawing my integers, when I had the 2 different colors, when I had negative 3 and positive 7, I put them so that they were stacked one above the other. And I'm use the example right here just to show you that. So I had the yellow on top, that was my negative, and I had the red on the bottom, that's my positive. And I lined them up underneath each other so that I could see how many were left over. Then it was easy to see what the answer to that question was, because we remember every negative and positive becomes 0. That's called the 0 principle. All right? So I'd like you to do all of them, but I want you to model at least 2 of these for homework using the colors, all right? And using them and actually making sure that you know which one is positive and which one is negative. So as soon as you've got those written down, you can go, girls. I think that's it, unless you have any questions. Bye, Lexi. Thanks. Bye, Jasmine. Have a good night.